Good morning. In the today's class, we are going to discuss about the length of the open belt drive. So now you can see in the picture that there are two pulleys, pulley A and pulley B. Let us take this is pulley A and this is pulley B of two different diameters. One is, or it can take it as radius. This one as a capital R and this one as a small r. Okay, then now, so you can see the two straight lines which are connecting the two pulleys is nothing but the total belt. So here we have to find out the total length of the belt. Okay, so here this is the center of the pulley 1, that is O1, and this is the center of the pulley 2, this is small pulley, and this is O2. And here you can see the belt is touch up to this particular point for this pulley, and this is touched at this particular point, and here also this is relieving at this point, and so this particular point at which the belt is leaving the pulley is what is the difference. This is angle. This angle is defined or denoted as alpha, and here also this is alpha, and here also it is alpha, this is also alpha. This alpha is known as angle of contact. What is that? Angle of contact between the belt and the pulley. So now let us take some of the few points here on the total length of the belt drive. That is, this is point A, and where the belt leaves this drive, this point is B, and where it touches is point C. This point is D. This point is E. Okay, this point is F. So here I have given the total number of points which is given riding on the two pulleys. Now, in a simple way, I can write the length of the open belt drive is nothing but 2 into, so from here, from this point you take AB and AF is equal, so that is why I am calculating only one of this side, so that if it is multiplied by 2 it will come on the both sides. So now 2 into, this is the arc AB, so write arc AB plus the distance, that is B and C, plus BC, plus what about this one, this is arc C and D. So now arc CD. So here arc CD is equal to this one, so that is CD and D are both one and the same, so that is 2 into arc CD. Then you can know how you can find out this arc AB. So arc AB, if you see here, so here this is the vertical axis of the pulley, so this is about 90 degrees. So arc AB, if you find out, this is 90 plus alpha. Okay, 90 plus alpha. So arc, see here, arc AB is equal to 90 plus alpha, and this is can also be written as pi by 2 plus alpha. Okay, so now I will write this equation in this form: 2 into pi by 2 plus alpha into, this is capital R, this is the capital R, plus BC plus arc CD. In the same way we can write down the same thing, that is, this is pi by 2 minus alpha. So here right once again I will write it at arc CD is equal to 90 minus alpha, that is equal to pi by 2 minus alpha, right? So here you write down, that is pi by 2 minus alpha into small r. Okay, so let us treat this is equation number 1, right? Now what you do is draw a line parallel to BC, draw a line parallel to BC from O2 to this line, okay, OB1, O1B. So if you draw a line parallel to this one, okay, this is a line drawn parallel to BC. So now you can get an angle of alpha here. So now this will be 90 degrees. Okay, 90 degrees. So now let us take this separate division here. So this one is O1, this one is O2, O1, O2. Okay, first draw a straight line. Then next just you draw a O1B line. So this point, let us take this point is B. Okay, and draw a line, so distance, so you take sum of the distance here and draw a line, and this one is alpha. Okay, so now what is this total distance? So the total distance from E1 and R is nothing but the outer radius of the pulley, that is capital R, and you have drawn the line parallel to this one. So the distance from OC, let us take another line here, this point is C. What is the distance between these 2 points? These 2 points is small r. Okay, small r. So here this is small r distance, this one, because these two are parallel lines. Let me change this pen. These two are in parallel, so this one is r and this one is also r. And what about this distance? The distance is nothing but r minus capital R minus small r, right? Let us, okay, now we want to find out the length of BC, right? So now you know the theorem, that is equal to under root of, okay, this, let us take this O1 to O2 is nothing but the length L. Let us take only L. This is L square minus this one opposite direction, so that is capital R minus small r whole square. Okay, so now let me take out this capital L outside, that is L into, that is under root of 1 minus capital R minus small r whole square. So let us take the complete root outside. Okay, that is nothing but L into, okay, 1 minus capital R minus small r whole square by L, because I am taking out of L, so this will be termed, L will be there here. This is total, this root cancellation goes to 1 by 2. Okay, now by using binomial distribution. Binomial distribution, can write it this equation as BC is equal to L into 1 minus, this half comes here, half, that is capital R minus small r by L to whole square, plus so on. This equation ends. Okay, then I'll write out this equation multiplying this one and here, that is L in minus 1 by 2 capital R minus small r whole square by L into this L. Okay, that is equal to L minus 1 by 2 into, this is L into R minus R whole square by L square. Just you separate it. This is also total. Okay, so L gets cancelled, and finally you will remain BC, the length, that is L minus R minus small r square by 2 into L. This is 2L. So this is BC. Then now let us go into this application of this value, BC value, into the equation number 1. This is BC value, right? So let us see here what happens. So now applying these values here, that is equal to 2 bracket begin pi by 2 plus alpha into capital R, plus bring this BC value here, that is L minus capital R minus small r square by 2L plus pi by 2 minus alpha into capital R. So I brought this value, this particular value, into the equation 1. So now I will multiply these two for all these equations and rewrite the equation as, that is equal to 2 into pi by 2, that's 2 gets cancelled, only you will have pi plus 2 alpha. This is pi into r, so this is 2 pi r into 2 alpha into capital R plus 2 into L, that is 2L, minus this 2 into R minus R square by 2L. This 2 gets cancelled, so this 1 by, this is R minus capital R minus small r square by L, you will get it, plus the same thing, 2 into pi by 2 small r, 2 gets cancelled, then this one gets pi small r minus 2 into alpha, this is 2 into alpha, this small r comes here. So now I will brought up this pi r one place and 2 alpha pi r at one place. So that is equal to, I will take it pi as a common here, this is capital R and this is small pi r plus r, plus 2 alpha as common, 2 alpha capital R, 2 alpha small r, that is R minus small r, then plus 2L, the remaining is minus R minus small r square by L is the remaining thing, right? Now I will rewrite the same equation, R square minus R square is nothing but R minus R into R minus R. So that is, I'll rewrite this, that is pi into R plus R plus 2 into alpha value. What is the alpha value? So alpha value here we can say sine alpha, see it here, sine alpha is equal to, sine alpha is equal to, anywhere for both the sum is same, that is capital R minus small r by L. As the alpha is very small, you can remove it the sign value, therefore alpha is equal to capital R minus small r by L. So this is the value of alpha. So you take this alpha value and put it here, that is capital R minus small r, and the same thing is, that is capital R minus small r by L. Okay, so here I forgot, plus 2L minus r minus small r square by L. So now here this is also 2r square, so I will rewrite it, pi into capital R plus small r plus 2 into capital R minus small r whole square by L minus, I'll bring this equation right here, r minus r whole square by L plus 2L. So here this is 2r square minus by L minus this one. So finally you will get out 2, that is pi into r plus r plus this one. So 2 of this coefficient and this coefficient gets 1, that is plus r minus r whole square by L plus 2L. So now this is the complete length of the open belt formula.